The preferred method to trip a ground fault circuit interrupter, or GFCI, is by connecting a 2-lead voltage or continuity tester between the hot and ground pins. This provides a reliable and safe way to test the functionality of the GFCI without creating a short circuit between the hot and neutral pins. GFCIs are designed to protect against electrical shock by tripping when they detect a difference in current between the hot and neutral conductors. By connecting a tester between the hot and ground pins, a current path is created through the ground wire. This simulates a ground fault and triggers the GFCI. An alternative method, which is not recommended, involves using a plug-in tester with a tripper button. This method is not recommended for several reasons. Firstly, there is the potential for damage. Pressing the tripper button creates a short circuit between the hot and neutral pins. This can damage the tester or the GFCI if it is not designed to withstand such a short circuit. Secondly, incorrect tripping can occur. Plug-in testers with tripper buttons may not always trip the GFCI correctly. They can sometimes trip the GFCI even when there is no fault, or they may fail to trip it when a fault is present. Therefore, for the safest and most reliable method of testing a GFCI, it is recommended to use a 2-lead voltage or continuity tester and connector between the hot and ground pins. This ensures that the GFCI is functioning properly and providing the intended protection against electrical shock. The 2-lead tester method simulates a real ground fault condition, which is what the GFCI is designed to detect. This provides a more accurate test of the GFCI's ability to protect against electrical hazards. Plug-in testers, on the other hand, create an artificial short circuit that may not accurately reflect real-world fault conditions. Additionally, repeatedly using the tripper button on a plug-in tester can weaken the GFCI mechanism over time, potentially leading to premature failure. The 2-lead tester method is also less likely to cause nuisance tripping. Nuisance tripping occurs when the GFCI trips even though there is no actual ground fault. This can be caused by various factors, such as electrical noise or minor fluctuations in the current. Plug-in testers are more susceptible to causing nuisance tripping because they create a sudden and abrupt change in the current flow. The 2-lead tester method, in contrast, creates a more gradual and controlled change in the current, reducing the risk of nuisance tripping. When using a 2-lead tester, it is important to ensure that the tester is properly rated for the voltage and current being tested. The tester should also be in good working condition with no damaged or frayed wires. Before testing any GFCI, it is always a good idea to visually inspect the outlet and the surrounding area for any signs of damage or hazards. If any damage is found, the outlet should not be tested until it has been repaired by a qualified electrician. To perform the 2-lead test, firstly turn off the power to the circuit at the breaker. Secondly, insert 1 lead of the tester into the hot slot of the outlet. Thirdly, insert the other lead of the tester into the ground slot of the outlet. Fourthly, turn the power back on at the breaker. If the GFCI is working properly, it should trip immediately. If the GFCI does not trip, it may be defective and should be replaced. After testing the GFCI, reset it by pressing the reset button on the outlet. It is important to test GFCIs regularly to ensure that they are functioning properly. The National Electrical Code, or NEC, recommends testing GFCIs at least once a month. However, some manufacturers recommend testing them more frequently. Testing GFCIs is an important part of maintaining electrical safety in any home or building. By following the recommended procedures and using the proper equipment, GFCIs can be tested safely and effectively to ensure that they are providing the intended protection against electrical shock. Remember to always prioritize safety when working with electricity. If you are not comfortable performing electrical work yourself, it is best to hire a qualified electrician. It's also worth mentioning that while the 2-lead tester is the preferred method, understanding the limitations of any testing method is crucial. A GFCI can still fail even if it passes the standard test. These tests primarily verify the tripping mechanism under simulated fault conditions. Factors like component aging, environmental conditions, or specific types of electrical faults can degrade a GFCI's performance over time, potentially leading to a failure to trip when a real ground fault occurs. Therefore, Regular testing, along with periodic visual inspections of the GFCI device itself, are essential for maintaining a safe electrical system. Furthermore, it is important to note that GFCIs are not a substitute for proper grounding. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. GFCIs provide an additional layer of protection by detecting even small amounts of current leakage to ground. In situations where grounding is not possible, such as in older homes with two-wire electrical systems, GFCIs can provide a significant safety benefit. However, it is always best to have a properly grounded electrical system whenever possible. When installing a GFCI, it is important to follow the manufacturer's instructions carefully. GFCIs are typically installed in locations where there is a risk of exposure to moisture, such as bathrooms, kitchens, and outdoor areas. They can be installed as receptacle outlets or as circuit breakers in the electrical panel. When replacing an existing outlet with a GFCI outlet, it is important to properly identify the line and load wires. The line wires are the wires that come from the electrical panel, and the load wires are the wires that go to other outlets or devices in the circuit. If the wires are not connected correctly, the GFCI will not function properly. If you are unsure about how to install a GFCI, it is best to hire a qualified electrician. In addition to testing GFCIs regularly, it is also important to be aware of the signs of a faulty GFCI. Some common signs include frequent tripping, failure to reset, and physical damage to the outlet. If you notice any of these signs, the GFCI should be replaced immediately. GFCIs are relatively inexpensive and easy to replace, so there's no reason to take a chance with a faulty device. By taking the time to test and maintain GFCIs, you can help to protect yourself and your family from electrical shock. Electrical safety should always be a top priority, and GFCIs are an important part of a safe electrical system. It is also important to remember that GFCIs are not designed to protect against overloads or short circuits. Overloads and short circuits can cause the circuit breaker to trip, but they will not necessarily cause the GFCI to trip. To protect against overloads and short circuits, it is important to use the correct size circuit breaker for the circuit. The circuit breaker should be sized according to the ampacity of the wires in the circuit. If the circuit breaker is too large, it will not trip in the event of an overload or short circuit, which could lead to a fire. In addition to GFCIs, there are other types of safety devices that can be used to protect against electrical hazards. One such device is an arc fault circuit interrupter, or SI. SIs are designed to protect against arc faults, which are a common cause of electrical fires. Arc faults occur when there is an unintended arc of electricity between two conductors. This can happen when wires are damaged or frayed, or when there is a loose connection. SIs detect the presence of arc faults and trip the circuit breaker to prevent a fire. SIs are typically installed in bedrooms and other areas where people are sleeping. They are required by the NEC in many new homes and renovations. Another type of safety device is a surge protector. Surge protectors are designed to protect against voltage surges, which can damage electronic equipment. Voltage surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protectors work by diverting excess voltage away from the electronic equipment. They are typically installed at the electrical panel or at the point of use. When choosing electrical safety devices, it is important to select products that are listed by a recognized testing laboratory, such as Underwriters Laboratories or UL. UL listing indicates that the product has been tested and meets certain safety standards. It is also important to follow the manufacturer's instructions carefully when installing and using electrical safety devices. Electrical safety is a shared responsibility. By taking the time to learn about electrical hazards and how to prevent them, everyone can help to create a safer environment. Always remember to turn off the power before working on any electrical equipment. Use caution when working near water. Never overload electrical circuits. Inspect electrical cords and plugs regularly for damage. Replace any damaged cords or plugs immediately. If you are not comfortable performing electrical work yourself, hire a qualified electrician. By following these simple tips, you can help to prevent electrical accidents and injuries. Electricity is a powerful force that can be dangerous if not handled properly. However, by taking the necessary precautions, you can safely enjoy the benefits of electricity. Furthermore, consider the environment in which the GFCI is operating. Locations with high humidity, corrosive atmospheres, or extreme temperature fluctuations can accelerate the degradation of internal components, potentially affecting its reliability. Regular inspections and testing should be more frequent in such environments. Also, be aware of the load connected to the GFCI protected circuit. Overloading a circuit can not only trip the breaker but can also put stress on the GFCI device. Ensure that the total load on the circuit is within the rated capacity of the GFCI and the circuit breaker. It is also important to educate others about the importance of GFCI protection and proper testing procedures. This includes family members, co-workers, and anyone else who may be using electrical equipment in areas protected by GFCIs. Make sure they understand how GFCIs work, how to test them, and what to do if they trip. By promoting electrical safety awareness, you can help to prevent accidents and injuries. Remember, GFCIs are a critical safety device that can save lives. By understanding how they work, how to test them, and how to maintain them, you can help to ensure that they're providing the intended protection against electrical shock. Prioritize electrical safety in all aspects of your life, and always consult with a qualified electrician if you have any questions or concerns.